All right, 8th graders, we're going to get started here with lesson 57, operations with small numbers in scientific notation. If you remember, 10 to the 5th, as they show here on your book, times 10 to the 3rd, that's going to equal 10 to the 8th because we add these two numbers. If we do 10 to the 5th divided by 10 to the 3rd, then we subtract these two numbers. 5 minus 3 is 2. So you see the two different types of answers. Okay, now if I were to multiply 10 times negative the 5th times 10 to the negative 3rd, again we would add those two numbers, and negative 5 plus negative 3 would equal negative 8. If we were to divide those numbers, we have negative 5 minus a negative 3, which would be actually negative 5 plus 3, so we'd be left with 10 to the negative 2. Okay. And then numbers as a negative, 10 times 5 times 10 to the negative 3rd, we'd have 5 plus a negative 3, so that would equal 10 squared, and 10 to the 5th over 10 to the negative 3rd, 5 minus a negative 3, that would be an 8. So we kind of see a reversal as we started out. This number up here was 8, and this is 2, but because of how we do the mathematics here, makes a big difference. Okay, let's go on to example 1. A sheet of notebook paper is 0.01 centimeters thick. How tall is a stack of 2,500 sheets of paper? And then express each number in scientific notation and perform the calculation. So my two numbers are these, so I've got to say 1 times, see if I can erase that here. 1 times 10, and I had to move it 1, 2, so to the negative 2. Put that in parentheses, and I'm going to multiply it by this number, which will be 2.5 times 10 to the 1, 2, 3, so times 10 to the 3rd. Put those in parentheses there, and now we deal with them. We deal with just the whole numbers. We don't try to deal with the exponents first because they're both 10. That makes it nice. We can do 1 and times 2.5. So 1 times 2.5 will equal 2.5. And here we have 10 to the negative 2 times 10 to the negative 3rd. So negative 2 plus 3 will equal a positive 1. So 10 to the 1, which will be a 10. So my answer is 25. So 2,500 sheets of paper will be 25 centimeters tall. Again, if we look back here, we do 1 times 2.5, and we do 10 to the negative 2nd times 10 to the 3rd. We deal with them individually here. We don't try to, multiply this times this or anything. Just deal with them individually here. So that works to try here. So we'll go through that. First we got 2.4 times 10 to the negative 6 times 2 times 10 to the negative 2. So again here we go 2.4 times 2. That'll be 4.8. Ten to the negative 6 plus negative 2 will be a negative 8. So 10 to the negative 8. So that's going to be our answer there. And then it says express each number, or no, perform each and express result in scientific notation. So we see that they've done that there. All right. Next, let's look at, so this is A, so we got room here for B. We have got 2.4 times 10 to the negative 8th. Because it's division, we don't have to worry so much about parentheses here. All right, 2.4 divided by 2, so we're just going to work on that there. Well, that's half of 24 is 12, so that'll be 1.2 times 10, and A negative 8 minus a negative 2 would actually be plus 2, so it would be a negative 6. So that would be our answer for B, 1.2 times 10 to the negative 6. Okay. All right. 4 times 10 to the negative 6 times 5 times 10 to the negative 4th. Again, we will do 4 times 5, and that's going to equal 20. 10 to the negative 6 plus 4, because it's really minus a negative 4, so plus 4 will be 10 to the, let's see here. Sorry, I was saying that wrong. Sorry, negative 6 plus, because we're adding here, plus a negative 4. So negative 6 plus a negative 4 would actually equal a negative 10. Now we're going to have to regroup that though and remake an adjustment. I need to move the decimal place that way, so I need to move that way, so that means that number has to get closer to increase, or in this case get closer to 0. So I would rewrite this problem as 2.0 times 10 to the negative 9th. Even though when we see this number go up, we say, oh, well, that should be an 11, but really that's getting smaller. We want to get bigger. So 2.0 times 10 to the negative 9th. All right. Last one here, D. 4 times 10 to the negative 8th over 5 times 10 to the negative 2. Over here we've got 4 divided by 5. So 4/5, 0.8. Times 10, and a negative 8 minus a negative 2 will really be plus 2. That would be a negative 6. Now, again, the decimal is in the wrong place here. I need to move it over the other side of the 8. Move it one place, so I'm moving it that way, so this number needs to decrease. So 8.0 times 10 to the negative 7th. Even though you might say, hang on, shouldn't that be a negative 5? This negative 6 shouldn't become negative 5. Nope, it decreases, and because we're in the negatives to decrease a negative, we've got it farther away from 0. Negative 7 is farther away from 0 than negative 6. So watch out for these types of problems where you're going to have to regroup after you're done because the decimal's in the wrong spot. All right, you can get started on your lesson practice or practice set here, 8th graders.